So today's lesson is we are talking about the single pole double throw switch. So those are the single pole double throws are switch connection diagram, and also this is for their switch toggle switch diagram. So this one I mentioned about the connection of single pole double throw switch and the switching diagram. So for the two is this is for the intermediate switch connection. When you do the intermediate switch, they are circuit diagram and also switching diagram. So this one you read this one, then we put the tutorial question. So answer question and answer for the tutorial question. So this is for the connection of the conjugate bending. When you make the conjugate bending, we also need to meet how to join the conjugate and also the circuit diagram or the connection diagram of electrical switchboard as well. This is for the heating cable. When you using the heating cable, there will be the maximum voltage, the current rating, maximum operating temperature, continuous export condition. There will also you can see that the heating the cable. This one is a connection diagram of the construction diagram of electrical switchboard. So this one you can see the electrical switchboard and also that they are connection diagram as well. Here is the connection of the catenary wire. So this lesson note you can read about the connection of catenary wire. So they are how to give a clip on the catenary wire, the component of the catenary wire. You can see on this diagram. And this one is a catenary support system. How the catenary wire is supported and how the catenary wire will be their characteristic of catenary wire. You can see that this one. This is for the spacing. When you are connecting the catenary wire to the spacing, there will be the depending on the span and insulated conductor, bare conductor, how to do the span. So you can see this page. This is for the safety testing. When you are testing the R resistance testing, safety testing, insulation resistance testing, correct polarity testing, and also that you also make aware of the to neutral wire, short circuit condition. Those are also you are aware of this slide. This is the question and answer for the catenary wire system. We have definition of the catenary wire system. The answer you can see it here. Then we're talking about the ASR 063. 063s are you have to read that those are nodes. Those are the connection diagram. Also the arc connection, arc protection. Those things you can also see it. So those video slides are the video. Also the conductive piping system, sprinkler system, gas water system. So those nodes are I explain you about the adding connection, adding protection. So those video slide you can see there's an up video as well as they are detailed connection diagram. So you have to read through those nodes. Those nodes are electrical protection. Those nodes are you can also see those nodes. And also those are the component of the electrical switch diagram. You can see it. And also we also talk about the capacitor. Supply electricity DC circuit. So capacitor and capacitors. CDF per circuit you have to revise. Lesson 12 the capacitor and capacitor. At the end of this session, students should be able to state the basic function and draw the standard symbol for the capacitor. Describe the construction of the capacitor, list the component of capacitor and state their applications. Say the relationship between capacitor and voltage and charge. Define and determine the time constant of the RC circuit. Calculate the instantaneous voltage and the current in the RC circuit. Why the capacitor? Electric component used to store the charge. So this is the positive charge on a positive plate. Here is a two plate. Within two plate, two metal plate, we put that insulation, separated by the insulation material. This is called a dielectric. Factor that affecting the capacitance. Dielectric strength, dielectric constant, divided per meter. Capacitor type is determined by a dielectric strength. Polyresistor is a general purpose capacitor. Paper capacitor is main voltage. And electrolyte is a polarized high capacitance for the small side. Titanium is a polarized high capacitance for very small side. And ceramic plastic is a kind of the capacitor. Air capacitor is low capacitance and variable. Dielectric, so dielectric is constant Farad per meter. Cross-sectional area of the plate is a A. And also distance between the plate is a D meter. And C equal to EA by D. The unit of capacitance is a farad. One farad is a law of the capacitance. So we use a microfarad and a picofarad as well. Symbols are the fixed. This is the most common symbol. Polarized, variable, trimmer. Those are the kind of the capacitor symbol. So there will be the voltage and the charge characteristic. So when the voltage increase, the electric charge will increase. So this is the del Q by del V. This is the farad. This is the capacitance you can calculate by this way. So Q equal to C into V. Q equal to C into V. When the capacitor is at 47 microfarad, voltage 100 volt. Q equal to CV. So that you substitute C equal to Q by V 47 into 10 power minus 100. You got a 0.47 microfarad. So supply voltage 25 volt, capacitor 100 microfarad. So Q equal to CV. So that means Q equal to 100 into 10 power minus into 25. You got a 2500 microcoulomb. We get it. Vs is the supply voltage. So there will be the current will flowing. In this case, a positive terminal and a negative terminal. All the charges are happening. So supply voltage Vs. When the current flowing, so this is electric current flow to capacitor. IT equal to the I maximum E power minus T by T. T equal to I into C. So this is a T, 2T, 3T, 4T, 5T. You can get it here. Then when the current time increase, the current will be going down. Correspondingly with the disk-graph. So disk-graph you can also draw it. And also the charge circuit, V equal to Vs into 1 minus E power minus T by T. T equal to RC. When the time increase, voltage will be increased. So voltage increasing, you can draw the disk-graph like this. And discharge circuit is this is the capacitor. When the voltage charge, already charged, and when the discharge, the current will be going down, going out, there will be the charge will be zero. So charge will be zero. So this is I equal to I maximum E power minus T by T. So T equal to RC, I maximum minus V by R. When there's a time increase, current will also be increased like this. This is a charge. In this discharge circuit, when the time going on, current will be going down like this. So this is discharge circuit. So this is a universal time constant graph, T equal to RC graph. You can also see like this. Current always start at the maximum. I equal to Vs by R. For the charge and discharge, current always fall. For the charge, voltage will be rising. So charge as a this diagram. For the discharge, voltage will fall. The charge down is at this diagram. So these are connection diagrams. The strict position A to B, 220 ohm and 100 microfarad capacitor are connected in series. Supply voltage 32 volts. So that when you say it connected to the B, V is equal to 0, VB equal to VA equal to 32 volts. So this is S equal to T equal to 0, straight from A to B. The current flow into here, I is equal to I, T equal to IR equal to 32 by 220, you got 145 milliampere. T equal to RC 220 multiplied by 100 microfarad, you got a 22 millisecond. After 110 millisecond, capacitor charge and the current stop. V equal to VCS equal to 32 volt and a VR equal to 0. And at the same time after, you can see the switch from the B to A. Then I is equal to I equal to IR equal to 32 by 220, you got the 145 milliampere. And the T equal to RC, so 220 multiplied by 100 microfarad, you got a 22 millisecond. After 110 millisecond, the capacitor discharge and the current stop. I equal to 0, VC equal to 0, VR equal to 0. Then you have to do the practical exercise. Then we are talking about another lesson. Lesson 13. Capacitor in series and parallel. Capacitor in series and parallel. At the end of this session, the student should be able to describe the reason for connecting the capacitor in series and parallel. Calculate and measure the equivalent capacitor in series and parallel circuits. Calculate the distribution of voltage and charge on capacitor in series and parallel. Measure the distribution of voltage on the capacitor in series and parallel. Determine the serviceability of capacitors in a state of common. Capacitor connected in series has the same current. So here C1, C2, C3, the same current flow. Capacitor connected in series has the same charge. The total charge on the group of capacitor connected in series is the same as the individual charge. QT equal to Q1 equal to Q2 equal to Q3. QT equal to CT multiplied by VT. So that in this case, when capacitor is connected in series, the V total equal to V1 plus V2 plus V3. QT by CT equal to Q1 and C1 plus Q2 by C2 plus Q3 by C3. You can get the current. So 1 by CT equal to 1 by C1 plus 1 by C2 plus 1 by C3. So the this is the equation for the capacitor connected in series. We can write down this equation. 10 microfarad, 15 microfarad, 25 microfarad, those wires are connected in series. So therefore the 1 by CT equal to 1 by 10 plus 1 by 15 plus 1 by 25. So CT equal to 4 by 84 microfarad, you got it. Then the QT equal to CT multiplied by VT. 10, 15 and 25 microfarad connected in series, supply voltage 100 volt. QT equal to 4 by 84 multiplied by 100. So you got the 484 microcoulomb, you got it. Then VT equal to V1 plus V2 plus V3. V equal to Q by C. So therefore, we write down that V1 equal to Q1 by C2. So 484 by 10, 488 by 8 volt, 48 by 4 volt. V2 equal to Q2 by C2, 484 by 15, you got a 32 by 27. V3 equal to Q3 by C3, 484 by 25, 90 by 36. So then you add everything. 484 by 4 plus 32 by 2 plus 90 by 4, you got 100 volt. 1 by C3 equal to 1 by C1 plus 1 by C2 plus 1 by C3. 8, 12 and 24 microfarads are connected in series. 1 by 8 plus 1 by 12 plus 1 by 24. CD equal to, you can calculate a CD. Then the CD multiplied VT is a 4 multiplied 400. You got the 1600 microcoulomb. Q together 1600 microcoulomb. V equal to V1 plus V2 by V3. So in this case, we calculate V1 into Q1 by C1. 1600 by 8, you got a 200 volt. You substitute. V2 equal to Q2 by C3. 1600 by 12, you got a 133 by 3 volt. V3 equal to Q3 by C3, 1600 divided by 24, you got a series by 7 volt. So you add everything, you got a voltage equal to 400 volt. Then capacitor connected in parallel. They draw a different current. So C1, C2, C3 are connected in parallel. The currents are I1, I2, I3. Also, there are different charges as well. So the C1 charge are Q1, C2 charge is Q3, C3 charge is Q3. The total charge on a group of capacitor connected in parallel is the sum of the individual charges. Q2 equal to Q1 plus Q2 plus Q3. So therefore, you got Q2 equal to CD multiplied VD. Q2 equal to Q1 plus Q2 plus Q3. Now CD VD plus equal to C1 V1 plus C2 V2 plus C3 V3. So CD equal to C1 plus C2 plus C3. Just like making the plate larger, make the equivalent capacitance larger. So the Q1, C1, C2, C3 are 10, 5, and 15. You add everything. CD equal to 5 plus 10 plus 15. You got the 30 microfarad. Q2 equal to Q1 plus Q2 plus Q3. CD equal to 30 microfarad. The current flow to the capacitor C1, I1, capacitor C2, I2, capacitor C3 is I3. That Q2 equal to Q1 plus Q2 plus Q3. Q1 equal to C1 V1 50 multiplied 5, 250 microcoulomb. Q2 equal to C2 V2 50 multiplied 10, 500 microcoulomb. Q3 equal to C3 V3 50 multiplied 50, 750 microcoulomb. So you add everything. Q2 equal to 250 plus 500 plus 750, you got that 1500 microcoulomb, you got it. Therefore, Q2 equal to 1500 microcoulomb. Then also that here capacitor 25, 50, 75 connected in parallel. CD equal to C1 plus C2 plus C3. So you substitute that value of C1, C2, C3. So 25 plus 50 plus 75, you got the 150 microfarad. Qt equal to Q1 plus Q2 plus Q3. Qt equal to Q1 plus Q2 plus Q3, you got it. Therefore, here you see the thing is a 25, 50, and 75 you add. So the Q1, Q2, Q3 is you add everything. So the Q1 is the C1, V1, 85 minus 25, Q1, 25. Q2 equal to C2, V2, 85 minus 50, 4250. Q3 equal to C3, V3, 85 minus 75, 6375. You add all the things. 2125 plus 42750 plus 6375, you got a 12750 microcoulomb, you got it. Qt equal to CD, PT is at Q1 equal to 150 multiplied by 85, so 12750. Then you have to do the practical exercise. Then we are talking about this is for the electrical engineering. Firstly, I explain you about the trade 1 and trade 2, so that you read them, view my video, and then you also view another video. Another video is no audio. You have to read the notes on the page. Then you have to study. This video is a guide. Today's lesson, there are two videos. This video, I explain about what to read and also what the lesson. Second video, without any audio, my intention is that you have to read the video and you have to read the pages on this video. So second video is the electrical trade 1 circuit diagram connection and the cable termination. Trade 2 is the circuit protection. Those things you have to view the video. So this video I explain how those video, which lesson you have to study. Now I'm talking about the electrical diploma. So the BAppEngLesson18A electrical electronic resources 1.HTN. This is the link. You can see that this link. These links are on this link. We find out the electrical diploma, advanced diploma, electrical engineering. So now I'm looking for those videos. So that you can see that the view is electrical diploma 2022.HTN. So you have to click this link. You can see the video. Electrical advanced diploma electrical. So that I'm looking for the video lesson. So here you can see the video lesson. YouTube video for electrical engineering lesson. So this things you click it, you can accept. You can also directly get the link IUI-college.com/electrical diploma. So that today's lesson is we are talking about the engineering mathematics. E1 to 6 are engineering mathematics. So this one you guys will see. So the highlight computer.com/video lesson.pdf. This is a written notes, and the videos are you have to view from the lesson 1 to lesson 13. So those are the electrical video, you can get it. You view the video and you read the notes. Those video lesson that you have to view the video lesson. So that the link is a IUI-college.com/electrical diploma 2022 study option 3.htm. So this is a link. So you can directly access this link. Access to this link and you click the lesson. You click the lesson, you get access to the video lesson. Then video lesson you find out until you find the E1 to 6 engineering mathematics. So you can see the engineering mathematics. Now you see the E1 to 6 engineering mathematics. So the written notes for the those video lesson slides are here. Highlight computer.com/video lesson.pdf. So you have to click and then you have to read the page 87 to page 101. Those are the written notes for the those video lesson. You have to view the video and also written notes are page 87 to 101. Highlight computer.com/video lesson.pdf. So that we see the one video. So that you can see that now I opening the video lesson. Video lesson, you look at the page 87 to page 101. Those are written notes for the video lesson. You have to view the video lesson and also you have to read the notes. Those notes are video slide. Video right side, you can see the written version. Page 87. So this is the lesson notes, so you have to read the notes and also you see the video lesson as well. So page 101. So this 87 to page 101. So I show you the one video example.
Only 2 years. So 3 8/50 plus 10 8/8 minus 4.
This is for the example of video. So the today's lesson, you have to view this video. These videos I explain you what to read for the electrical trade 1 and trade 2. Also the advanced diploma electrical engineering as well as electrical DC circuit for the bachelor applied engineering electrical. So now I repeat again how to get the advanced diploma electrical engineering lesson. You go to the lesson here. So you have to from this side. Now you can get the video lesson. Then you have to view the video and you can see the lesson notes.